Now I'm going to discuss the NP array iteration. Iteration is nothing but accessing every element of an array, and iteration can be done with loops. First of all, I'm going to discuss the iteration using the for loop. Here we have successfully created a array b equal to np dot array 1 2 3 4. We have successfully created a b array, and to access the elements of that b, we're gonna use a for loop. For I in b, we're gonna access that element I, and it's gonna access every element of this array 1 2 3 4. As we can have a look at into here, we have successfully accessed it. What if it is a two-dimensional array? If it is a two-dimensional array, if you try to access the elements of that two-dimensional array, I just run it. As you can have a look at here, to access a two-dimensional array, it has just accessed the whole row. We don't want that, therefore we're gonna use the extra for loop. For j in I want to access the j, and I just add a space here. I just run this particular program. As you can have a look at here, it's gonna access every other element. If I use a three-dimensional array, for example here, I just add a new bracket and I just run this and I just run this, it's gonna access the row. Why? Because we have only used two for loops for accessing a three-dimensional array. In such case, I have to use another for loop. For k in j, I'm gonna access the k. I just run this and I just run this. As you can have a look at here, we can able to access every other element of this particular array. And as you can have a look at here, to access a array element with respect to its dimension, we are increasing the number of for loops. For example, to access a 1D array, we have used only one for loop. To access a two-dimensional array, we have used two for loops. For accessing three-dimensional array, we have used three for loops. Just like that, to access an n-dimensional array, we require n for loops. To figure this problem, we have introduced with a new concept called ND iteration, in which we're gonna use only one for loop, and after that we're gonna use np dot nd iter, and we have to mention that particular array, and we have to print that particular I, and you just have to run this. When you do like this, it's gonna access every other element. You just have a clear look into here. It's actually a three-dimensional array, and we are accessing the three-dimensional array using only one for loop because of this np dot nd iteration, and this is why we're gonna use this. And after this, what if you want to change the data type of the element whatever you are accessing? For example, you have 1 2 3 4. It's actually a integer array, and you want to change the integer array elements into a string elements. In such case, you have something called operational data types, in which you're gonna use flags equal to buffered, because this numpy array, it's not going to disturb the original array, rather than it's going to create a new array and it's going to change the array data type. Therefore we're gonna use the flags, because it is going to create a new array. And after that, here we have to use operational data types equal to string, because I want the element is to be in string. Therefore I am going to say the operational data types equal to string. I just run here, and as you can have a look at here, we got our every other element using the b. That means the elements are in a string data type. After this, I am going to discuss about the step size. As I already discussed, step size is nothing but accessing those elements whose indexes are divisible by the step size. If you mention step size as 2, and as you can have a look at here, we have elements like 0 1 2 3. Actually the indices of this one is 0 and it will end at 3, and here the indices of 1 is 0 and 0 is divisible by 2. Therefore we're gonna access the first element and the second element, that is actually 3, and this is how we're gonna go with the step size. And I'm going to create that means accessing the element with respect to the step size. First of all, I'm going to create this as a 2D array. I just run this, and I'm going to remove these all the things. And as you can have a look at here, to access a two-dimensional array, we require two arguments in this particular square bracket. First of all, I'm going to use a colon, therefore I'm going to use 2 colon and 2. Why? Whenever we use a single colon, it's gonna access every element of this particular array. And after that, when we use colon colon 2, it's gonna access those elements whose indices are divisible by 2. So can I have a look at here? When I just run this, it's gonna access 1 3. Why? Because 1 is at a 0th position and 3 is at a second position, therefore it is gonna access 1 3. And this is how we gonna go with array iteration using the step size. After this, I am going to discuss about the enumeration. Enumeration is nothing but presenting the sequence number of that particular array element. For example, here we have our element. We have successfully created an array, a 2D array, and I just mentioned 5 6 7 8 here. As you can have a look at here, we have two-dimensional array with 8 elements in it. And I just remove these all the things, and I am going to mention nd because we are explaining about the enumeration. I just remove this. I'm going to mention nd enumerate, and I have to mention the array because we have the array here, and I have to print two elements. Like here I'm going to have for I comma j, this particular I element is gonna store a tuple that containing the sequence number of that particular array element, and next we have the array element. For example, I just run this and I'm going to run this again. As you can have a look at here, we got the element with respect to their sequence number. At 0 0 position we have 1, at 0 1 position we have 2, at 0 2 position we have 3, 0 3 position we have 4, and 1 0 position we have 5. And this is how we gonna access the element with its sequence number. And this is all about the iteration and enumeration. I'm going to discuss about joining of the two arrays in the NumPy. Well, we can able to join the two arrays using the concat method, and we have also some of the methods like a stack. First of all, I'm going to use the two arrays, array A equal to 1 2 3 4 and array B equal to 1 2 3 4, and I just run this, and I'm going to create a new code. In this code, I'm going to create a new array, and I'm going to use the np concat method, in which I'm going to use concatenate method, and here I'm going to use the two array A comma B, and I'm going to print a new array a double r, and I'm going to run this particular program. As you can have a look at here, we have successfully merged the two arrays, and we have created a new array a double r, that is a longest array that we have created with the addition of a merging of both array A and array B. And here, as you can have a look at here, it has merged the elements in the x-axis or in the vertical manner. What if you want in the horizontal manner? We can have some of the method like axis, but it is not gonna work with it. If I use axis equal to 1, it's gonna work if it has a two-dimensional array, but if it is a single-dimensional array, it is not gonna work. In such case, we're gonna use something called as a stack. If I use a stack here, like we have the stack method. If I use stack and I just rerun this particular program, as you can have a look at here, we have successfully created a new array that is created in a horizontal manner rather than in a vertical manner. And this is how we gonna go with the stack method. After that, we have the same concatenation method with the horizontal stack, like h stack. And I just rerun this particular program. As you can have a look at here, without using the concat method, using the horizontal stack, we can able to merge the two arrays in the vertical manner. And we have vstack. If you use a vstack, it's gonna create the elements in the format of the horizontal manner. And we have something called as a d stack. If we use a d stack, it's gonna create the element with respect to the axis, like this is the first element and this is the first element, both are combined, and we have successfully created an array. And this is what a d stack gonna do. But here what happens, it's gonna create a three-dimensional array if you have added the two single dimensional array, because to create a depth stack, it's gonna take a lot of time. Therefore it's gonna merge the first element with the first element, and second element with the second element, third element with the third element, fourth element with the fourth element, and it's gonna create a new array in which both the elements are pushed together. And this is something called stack. And here if you mention the axis equal to 1, it's gonna do the same thing like what this stack had done. It's gonna do the same thing, but with the a normal dimension. Like here we have the single dimension, it's gonna create a two-dimensional, and the three-dimensional array is created if you use the D stack. And this is all about how we gonna go with the merging of the arrays. And here I'm going to discuss the same thing with two-dimensional array like 5 6 7 8. I'm going to create here, and here I'm going to use the same thing, like I'm going to use 5 6 7 8, and I'm going to create this. And first of all I'm going to use the concat method, like I'm using the concatenate method, and I'm going to remove this access, and I'm going to run this particular program. First of all I'm going to run this, and after this I'm going to run this. As you can have a look at here, we have successfully created the array, but the problem is that it is added in horizontal manner. When we use a single dimensional array, it is going to be added in vertical fashion, but when we use the two-dimensional array, it is added in horizontal fashion. But we don't want that. In such case, what we have to do, we have to use the access equal to 1, and we just have to run this. When I run this particular program, as you can have a look at here, we have successfully added the first row with the first element, the first row of A equal to first row of B, and first row of second row of A with the second row of B, and this is how we're gonna go with it. And what if we use stack method here? If I use stack method and just run this, as you can have a look at here, the same operation is done in different manner. Here the stack has added the first row with the first row of this B, and with new array. And if we don't mention the access here, it's gonna do the same operation in different manner. As you can have a look at here, in the different manner. And with the edge stack, it's gonna do the same thing. I just use edge stack with the vertical stack. It's gonna do the operation with a different manner. And after that we have something called D stack. It is with a different manner. As you can have a look at here, every element is added, and this is all about it. Well, do subscribe our channel for regular updates. Thank you.